practices, and what are the enterprise standardizations. Uh, a quick refresher about containers. So containerization is a operating system level virtualization technique or an application level virtualization technique where you can basically run isolated applications where you also have isolation of network resources and in general CPU resources so that they can run in isolated spaces. These isolated spaces are called containers. So these are like vendorless, so you can run it on basically like any cloud or non-cloud environment. You have a host operating system, and typically you have the Docker daemon or any other containerization technology that's running on top of your host operating system, and then it basically just manages all of these applications. This is a quick reference about what containers do. They use two techniques that are present in the Linux kernel, which is called C groups and namespaces. C groups allows you to organize like processes into groups and usage resources based and resource like limit and monitor resources that are allocated by the CPU. And namespaces basically wraps the global system resources in an abstraction that allows you to allows you to have the process have the belief that it's like running in its own isolated environment and it cannot like reach to other processes that are running on the uh, in the containerization environment. So this is a quick refresher about how Docker architecture works. You have a Docker client and you have a Docker daemon or Docker server, and then you have the Docker registry. In most cases, the Docker client and the host is running on the same system, and they essentially like interact over a REST API. And the Docker daemon is basically the brains of the system that is responsible for managing the life cycle of the container. And the Docker registry hosts all of these images. So these are some of the industry standards and containerization technologies that you have. Podman is something that's really coming up right now because of some of the enterprise level changes that Docker has made, like, you know, forcing people to pay for a lot of stuff and adding a paywall for features that were previously free. Podman is really good. It's written in Golang. It's completely open source. And these are some of the other technologies. LXD is, I think, by Canonical. So these are some of the industry standards and recommendations. You have some standards by the US DoD. You have NIST standards and the CSVS standards that which is called Container Security Verification Standard, which is by OWASP. Um, so US DoD basically created this hardened container requirement, and they have a registry of all the repos, which is called Iron Bank. It is a container repository that has all of the like compliant containers. And the NIST standard is essentially a um, containerization security standard. Uh, I'm going to quickly go through this. This is like essentially OCI or the Open Container Initiative, which has specifications about the runtime, the image, and the distribution. I'm not going to go over this right now, but I'm straight going to jump into what are the things that we look for in containerization security. So we look for how to secure the container host, the network traffic that is going in and out of the container, the security of the application that is running within the container, and integrity and security of the build pipeline, security of the container management stack that we saw. So essentially the daemon, the client, the host operating system, and the infrastructure, and the security of the foundational layer of the application. So a Docker image is basically an image that is in layers. So it uses a technology called Union File System, which essentially has multiple layers of images. And an image is based off of a foundational layer. So it's essentially like you typically in a Docker file, you write from, say, Ubuntu or it's any kind of base image, and you basically write your image on top of that. So you talk about the security of these foundational layers. And of course, we know these secure design principles that we need to keep in mind. I won't go over in detail about what exactly each principle is because I'm sure everyone must be knowing about this. Um, let's talk about the security of the container host. So the first thing that we note is to choose operating systems that are optimized for containerizations. And the obvious answer here is Linux. because even if you're like running Docker or any kind of containerization technology on Mac OS, it essentially is running a Linux VM, which is running your Docker containers. Windows has come up with their own containerization technology, but it only works for Windows operating system or Windows-based containers. Um, and so the right optimized operating system would be to deploy everything on Linux. Um, and the second thing is hardening the host operating system. So you basically just remove all of the services that you don't want, because there might be some stuff on the host operating system that someone can leverage through the Docker containers and essentially exploit those services, escape the Docker containers, and gain access to your system. Some of the things that you can also do for your host would be to use access control list, security profiles, seccomp, or IPS. And there's a new technology that it was introduced by Google called as application kernels. So this is essentially like they have a dedicated or devoted application layer kernel that runs for every container. So it essentially like protects your host operating system from kernel exploits. Like for example, if there is a dirty pipe exploit or even dirty cow, which was found in the Linux kernel. So it essentially like protects your containers from, like, if someone gets access to your container and he is able to like run these kernel level exploits, they can like essentially compromise the host system, because all of the containers are essentially running on the host operating system. So these applications kernels protects you from these kind of kernel level exploits. And keeping your software up to date is obviously one of the most important things to do. Um, and you need to run signed images, so that essentially like unsigned images could be contain malicious stuff. So running signed images. The second tip for security of the containerization applications would be to prevent any kind of escalation attempts. So always run your application as a non-root user and slim or strip down the container image to completely reduce attack vector. So if you're like using a Debian image with Apache, there's no need to have like Nginx or any kind of other service that's running on the container. And avoid mounting host volumes unless it's absolutely necessary, and make sure you don't mount the slash, because you'll essentially like gain access to the etc directory for the host directory. And if you have root access within the container, you can easily escalate to the host if you have directly mounted the slash. Um, and there is an option to like enable user namespaces in Docker, which essentially protects you from uh, running non-root inside of the container. And there's another flag here to prevent SUID and STID based escalation attacks. Um, Moving on to the next one. Um, then we have the security of the container management stack. So here we basically just talk about protecting or securing the container management or orchestration system. So you basically securely store your registry keys in the orchestration, securely store your registry keys for the orchestration system. Limit resources to prevent like any kind of fork bombs or denial of service attacks by abusing like CPU or memory or file descriptors. Make the file system read only whenever needed, and use tempfs, which is a essentially if the container just stops running, the tempfs file system clears off everything that was persisted for the container. And obviously enable logging, so that if once you integrate your container stack technology with something like Splunk, you can keep track of what's going on, or even like an intrusion detection or prevention system. Logging always helps, because this kind of data helps these systems to monitor your container stack for security issues. There is a thing called rootless containers, where you can like run Docker without actually having root, and even Podman supports that, which is actually a secure way, because if someone escapes the container, he can get into the user, and if the user is in the Docker group, he can escalate to root, which is pretty straightforward. Um, Now, the next thing is about tackling network traffic. So exposing the Docker daemon socket is always a bad idea, because you can essentially communicate with the socket if it's like mounted in the file system. So you can uh, through any kind of network interface, you can just communicate with it. So make sure that only learns from the loopback interface. because if there is any other machine that's running inside the network, and if the daemon socket is exposed to that interface of the network, any machine can like remotely access the Docker system that is running on the VM. Um, and make sure to like disable inter-container communication, because every time you spin up a container, it creates a bridge network. So essentially, the containers can talk over the bridge network. So if you really don't want containers to talk to each other, you should disable that. And of course, like disable SSH, RDP, or any command to prevent any form of network management activities inside of the container. Log and monitor your traffic using Splunk. There are several other open source tools as well. And another thing to note is to disable root for network services. So typically, like any if you're running a service that needs a port that is less than 1024, you need root access for that. But you can disable that feature with the netbind service capability that you have um, in Docker. So you essentially you don't need root to run these services for ports less than 1024. Um, this is another important thing to note is to have security and integrity of the build pipeline, to make sure you rotate the security keys, the certificates after regular intervals, store your configuration secrets, secret management solution. HashiCorp is a popular solution that a lot of people use. Use role-based access control to prevent arbitrary reads and writes. Um, and check if the base images are specified by the image hash, because there have been several attacks where people have like changed, they've taken over the name basically. And so if, for example, if you do from Ubuntu 2004, and if just someone just takes the tag in the Docker registry of Ubuntu, you can like essentially have a malicious image, and you will be essentially pulling from that. So you always reference the base image by the image hash and not the name, so that you make sure that you're pulling the right image from the registry. And there is another way to see what's going on with your container is through static analysis. There are several tools like Threat Mapper and JFrog X-ray that can analyze your Docker files and your containers for like secrets, just like what Nosy Parker does, but this is for like Docker files and the container specifically. And there are several websites that also allows you to check for any Docker misconfigurations. And linters, obviously, to scan the Docker file for security issues while you're writing them. So this is like an example. So Docker itself has their own vulnerability scanner, and this is how it kind of looks for that. It'll like essentially just find out which of the softwares that you're running inside of the container are vulnerable and which are not. So like to summarize, these are the best practices. You essentially secure your code and dependencies. You start from the ground up. You make sure like your application itself is secure. You start with minimal base images from a trusted source. You make sure that you only run whatever you need and not any unnecessary services. Use access control policies. Safeguard the entire infrastructure, including the network stack and the container stack, and have control over the layers between your base image and your application layer. And yeah, so that's it. I know this was like pretty quick, so I'll make sure to add all of the slides so that you can like go through each of them in detail. And I'll be open for questions.